In this video, we're going to explore relationships. Relationships as they pertain to science. So, all relationships, mathematically speaking, scientifically speaking, contain one or more variables. A variable is a component in an experiment that can be changed. The types of variables that we deal with are the independent variable, which is a variable that is selected to be changed in an experiment. You may also know it as the manipulated variable. And the dependent variable. This is the variable being tested. It is also known as the responding variable because it depends on the independent variable. On a set of axes, the independent variable goes on the x, and the dependent variable goes on the y. Most experiments, time is the independent variable because you choose, I'm going to measure every 10 minutes, I'm going to measure every hour, so on, so forth. And how you decide to measure, when you decide to measure, that's going to affect your dependent variable because that depends on the time in which you measure. So let's look at an example. A researcher is curious to find out what effect classical music has on people's level of relaxation. He suspects that listening to classical music will help people feel more calm and relaxed. So he lets one group listen to classical music for 1 hour. He lets another group sit in a quiet room for 1 hour, meaning they hear no music. And after 1 hour, he monitors the heart rate of each participant to measure their level of relaxation, meaning the lower your heart rate, the more relaxed you should be. Makes sense? So in this example, what's the independent variable and what's the dependent variable? What's being selected to be measured and what's only happening because of what we selected? So the independent variable is going to be the time that you spend listening to music, because that's going to affect your heart rate, supposedly. So the selection, the independent variable, the manipulated one, is how many hours you listen to relaxing music, and that should cause a change in your heart rate. So the heart rate is your dependent variable. And on a set of axes, it would look like this. So that's really how we're going to use those two variables, and we'll use them a lot. In most scientific experiments, it's important to control variables. Controlling variables means that the researcher, the person doing the experiment, is going to control certain variables and keep them constant. That's what it means to control them. This makes sure that the outcome, whatever it may be, is only the result of the variable that we allowed to change. It works better if I give you an example. So let's say a researcher is studying the effect of light on plant growth. So let's say they take two plants and they place one of those plants in a dark room and one of the plants in a room with light. All right? So they decide to measure every hour or what the height of the plant would be. So that's the experiment. But in order to do this and make sure that the sunlight was the only factor that made a difference in these two setups, the researcher would have to make sure certain things are always the same. And those could be, for example, the type of plant. They'd have to be both the same type of plant because different plants grow very differently in different conditions. How much water they would get. So even though one was in the dark and one was in the light, they'd still get the same amount of water, the same type of water. They'd have to be in the same type of soil, and they have to receive the same fertilizer. There's probably more variables that I listed here that need to be controlled, but it gives you an idea why. Because by controlling these variables, at the end of the experiment, we know, or we can actually say, the researcher can say that whatever change took place was only because of the sunlight, the lack of sunlight for one, and the sunlight for the other. And that's really what it means to perform what's called a controlled variable. In earth science and any science, along with math, relationships can be expressed using a graph. So a relationship on a graph is really the way that the two variables interact. All right. How the relationship appears can be described in one of four ways. So the first way is called a direct or positive relationship. And we say that as x increases, Y increases. So in a direct relationship, the arrow should be pointing up. That means as I go higher and higher for my X, I go higher and higher for my Y. So if I were to graph the hours you spend studying versus your grades on the test, those two things should agree, and the more hours you spend studying, the higher your grades were going to be on the test. So that's a direct relationship, a positive relationship. An indirect or negative relationship shows a decreasing relationship, an arrow pointing down. We say as X increases, Y decreases. So as I get to higher values of X, the Y value actually goes down. So they're oppositely related in this case. So for example, if as the price of basketball tickets goes up, as they get to higher and higher prices, the attendance at games are going to decrease because people aren't going to want to pay those prices. So that's an example of a indirect or a negative relationship. Static relationships, also known as constant relationships, don't change. As the X variable increases, the Y variable stays the same. So we call that static or constant. And a cyclic relationship is a repeating pattern, and that means that whatever change is taking place is doing so in the same pattern over and over again. So as X increases, Y is going to fluctuate according to whatever data related in a predictable pattern. So we can use this type of information to make predictions because of the repetitive nature of the relationship. So an example of that would be tides. I can tell you the tides for the next couple of days based on moon phases and the current tide situation. Whenever we look at a graph, no matter what type of relationship we're talking about, there's always a way to reference the rate of change. And the rate of change has a formula, which is on your reference table, but it really means the slope. So when we look at information on a graph, how the information data gets graphed tells us a lot about how quickly the change is taking place. So the red arrow has a very low slope, very gradual slope, whereas the blue arrow is a very steep slope. So the steeper the slope, right, the more vertical the arrow, the quicker the change is taking place.